Crash Course Instrumentation Saturday History Special Episode 6 Title Georg Ohm's Discovery, A Law Against All Odds. Before resistors had color codes and circuit boards ruled the lab bench, there was a lonely schoolteacher with a galvanometer and a dream. In this episode, we explore the unlikely journey of Georg Simon Ohm and how his stubborn search for mathematical relationships in circuits laid the groundwork for modern electrical engineering. Who was Georg Ohm? Born in Erlangen, Bavaria in 1789, Ohm came from modest beginnings. His father was a self-taught locksmith who gave Georg and his brother a rigorous informal education in mathematics and science. Although Georg later studied at the University of Erlangen, financial struggles forced him to leave and take up teaching. Struggle for recognition. Ohm's work culminated in his 1827 book, Die Galvanische Kette, Mathematische Bearbeitet. The galvanic circuit investigated mathematically. In it, he proposed a simple but powerful relationship. The current in a conductor is directly proportional to the potential difference and inversely proportional to the resistance. This idea, Ohm's law, was revolutionary yet widely dismissed at first. Critics called it speculative and unproven, and German scientific institutions initially rejected it. Persistence pays off. Despite the backlash, Ohm continued teaching and refining his theories. By the mid-19th century, his work was vindicated as scientists across Europe confirmed his findings through experiment. Eventually, Ohm received accolades including the prestigious Copley Medal from the Royal Society in 1841. Lasting legacy. Ohm's law, VHIR, is now one of the most foundational equations in electrical engineering. The ohm, O, the unit of electrical resistance, was named in his honor in 1881 by the International Electrical Congress. Fun fact: Ohm's original apparatus used a thermocouple to generate voltage and a galvanometer to measure current. Rudimentary but ingenious. He varied the wire length to observe changes in current, laying the first bricks of what we now call circuit theory. Why it matters today. Understanding Ohm's law is not just about solving textbook problems. It's about grasping how energy moves through systems. It's the Rosetta Stone of analog electronics and a launch pad for everything from sensors to signal processing. Thanks to this episode is inspired by the open-source models developed by Tony Kupalt and the Socratic electronics community. Check out the full source here. http://ibiblio.org Kupalt Socratic model/index HTML. Don't forget to like, share, and subscribe to Crash Course Instrumentation for more deep dives and quick hits every week.